Okay, this is great. So it's really a pleasure to introduce Federico. Federico is a fellow Italian, first of all, and then he's a fellow physicist. He got a PhD in quantum information, if I'm not wrong. And then, however, he decided to move in a career trajectory that is in the editorial area, and so he joined first nature physics, and then he went into nature communication for some time. And really, actually, Federico there was able to completely change the positioning of network science and some of the data, the work we do on network science and data within nature communication. And then I think it's now 1 year or 1 year, almost a bit more than 1 year that he's back as a senior editor on Nature Physics. And so for physicists, you know, he's one of the most powerful person. Your career is decided by him. You know,
thank you for putting pressure.
You know. And he will tell us about, how to say, an inside view in how it works Nature Physics, and especially, I think, the editorial desk rejections and things like that, you know. No. But for who was not at network science, at the network science conference in Paris, we had a very nice session there in which he was really talking about all the editorial work and workflow. So please, if at the end of the talk you want to ask some question, also very provocative, but just do it, because Federico is already, how to say, vaccinated, and is very happy to take any question. Okay, Federico, thank you very much.
Thanks a lot, Alex. Thanks a lot for having me here. It's really quite a pleasure. I've heard about this place a lot, so it's nice to see it in person. So with respect to what I said in Paris, this is going to be a little bit more structured, but I'm happy to take questions. Feel free to interrupt me if you feel outraged by what I say. You know, feel free to say it. And I think it's better if we have a bit of a discussion, so I'll try to keep it brief. But I just basically want to sort of like explain you a bit what we do. And since the audience is rather on the young side, I'm gonna kind of like try to unpack a bit the black box that is what's behind us. So as just a little bit, as Alex said, I'm a physicist. I did my PhD in physics, and as I'm gonna mention in a second, pretty much everybody who works as an editor at Nature has been a researcher, but then they moved careers and they stopped being a researcher. So I did my PhD in Germany, and then, well, pretty much like Alex said, first Nature Physics, then Nature Communications, then Nature Physics. Now, normally I start my talk asking the audience this question. I think that here is the only place where you actually know it better than we do. But still, I think it's a good starting point. So, do you have an idea of how many papers are published in physics? Of course, physics is ill-defined. I could have asked you network science. It's even probably harder. But let's say roughly.
10,000.
10,000. Somebody disagrees?
Yes, physics papers.
I mean, if you think about applied physics, I would say
together, so between 10 and 100,000.
One order of magnitude, okay. Anybody has a different opinion? I think the most important question is, however, let's say, keeping in mind what Lazo said, how many do you actually read? Right? Of course, even read is a bit of an ill-defined question, you know, but, you know, I leave it open to you. How many do you read?
What do you mean read?
Just answer, imagine your own interpretation of reading. And Okay. So let's say we go from 10,000 to 100,000 published, and you read 100. So, according to some very probably not clearly defined statistics, we estimated that 2015 it was around 250,000 papers. Not on the archive, peer reviewed, but of course this extends to applied physics and so on. But you know, it's a pretty substantial number. Even 10,000 is a substantial number. This is even bigger. And according to a survey that Nature ran a few years ago, researchers say that they read around 264 a year. This is where what exactly reading means, you know, it's a fine print. But let's say maybe like skimming the abstract and checking the figures and so on. So clearly, basically, the bottom, yes?
Is there a way to measure and quantify how many papers are actually cited? I mean, they obtained a result that was extremely important, a key result needed for this next paper to be.
There was a piece on Nature a few months ago. I don't have the reference here, but I can dig it up for you. Where they actually looked at how many papers have 0 citations in the literature, and it's something like 75% of the whole literature. So, but then the question is again like 0 citations. You know, maybe even telling somebody that you can't do something might be useful. It's hard to say. Still, basically, the point is, literature is massive, as you know, and grappling with it is really extremely difficult. So this is where, you know, a bunch of companies, more or less for profit, come in and try to offer some way of grouping all this literature into journals and sort of like giving you a little bit of a way to maybe make sense of all this and, you know, sort of like serve you by helping you understand what probably, you know, could be worth your time reading or not. Of course, different publishers have very different approaches to how they actually do it. Of course, I'm going to focus on us, so Nature. And the way we run our things is, you know, as you will see, a little bit different from the way other people run it. There are pros and cons in both ways. But basically, just to kind of give you a flavor, Nature was launched 150 years ago in a year. And from the very beginning, like in the first issue of Nature, the idea behind this magazine, which was clearly a magazine from a for-profit company, they launched this magazine to do 2 things. The first one was to place before the general public the result of the scientific discovery, and the second one was to help scientists to learn about the advances in all branches of natural knowledge. So basically, it's 2 things, right? On the one hand, is letting the public know how amazing, you know, the new amazing things that the scientists are figuring out. And the second one is actually giving a platform for scientists to talk to one another and learn about what's going on in all the science around them. Of course, in 150 years, the way you actually do it changed a lot. But the idea behind it, it's kind of similar. So basically, the way we run the Nature branch of our company is really basically following these sort of principles. So how is actually this done today? As you probably know, Nature multiplied, and there are quite a few journals out there. And the idea is, you know, trying to do this, but coping with the volume of papers that are published these days. And so really the way we try to organize this is by creating an ecosystem of journals, if you want, each of which is really tailored to addressing a specific kind of audience. And we really try to complement one another in order to still serve the public and to serve the scientific community by giving them platforms where to discuss. So this is kind of a breakdown of the journals that we have. But all of them basically, all the journals which have Nature in the name. So as you know, we own quite a, like the company owns a big share of journals. But really, what I'm talking about are those with Nature in the name. And as you will see, you know, despite the fact that they actually look for different audiences and they cater to different communities, they all share the same ethos behind them. And this kind of like driving system is really what characterizes the way we approach publishing. And this is basically the fact that we try to be very selective. We really try to be serving you by, in a sense, offering a filtering service. So we try to select something that we feel is worth your time reading. Now, who is you depends on the journal, but really the idea is there is so much literature out there, let's find what we feel people will really, you know, benefit from spending time reading. And this is done by full-time editors like me, so people that were researchers but then moved into being editors full-time. And we do this by remaining independent of external affiliations or societies or editorial boards. So everything you see in a Nature journal has been accepted by an editor. There is no, let's say, academics, of course, are involved in terms of reviewing process, but the decision is always with the editor only. Different journals are independent, but we all kind of fall under the same umbrella. So when I say editorially independent, it means tomorrow there might be the greatest paper ever in Nature, and I have no idea of knowing. We just don't know what's coming up, what's in the inbox of the other journals. We're independent, and this is also an opportunity for researchers to have a clear start in case something doesn't work at one journal. You can go at the other. But really, despite the fact that we have this big, let's say, stable of journals, where to submit is your choice. We're not moving papers around. It's really up to you. You decide which audience you want to reach, and that's where you submit your paper. So, since I think it's more interesting to have a conversation, I'll try to skip a bit quickly through the hierarchy, also because you're probably familiar with it. Essentially, Nature publishes around 800 to 1,000 papers a year, and what they really try to do is showcase the most important results in science. Again, to let the people out there, the laymen, know what's been done in science, but also to let the other researchers be updated on what happens. Then you have below them, below Nature, you have what are called the Nature branded research journals, and they look for, already you see that the kind of the scope is getting narrower, right? When editors at a specific Nature journal, they actually look for papers that can be interesting to specific communities, no longer to the whole world. And they publish like between 100 and 200 papers a year, so really catering for communities. So these journals, not many people know, but actually they go back quite some time, but of course in the life sciences first, because that's where the company always looks for us. And the first one was Biotech in 1983. Then at some point they realized that the physical sciences are actually a thing, and from 2002, with Nature Materials, we actually moved into the natural science, the physical sciences, sorry. But I think one interesting thing that I wanted to flag you, and I think it goes in line with what I mentioned before, is the fact that since a few years we actually launched these thematic journals, which really, the idea behind these journals is to create a platform where important challenges, if you want, you can call them societal challenges, get addressed by, a plethora of different researchers coming from different communities and giving them one single platform where they can meet. So issues like climate change or energy sustainability, where really the problems can't be solved only from the natural science angle, but perhaps also benefit from the input and require the input of social science. They cannot come together and actually discuss these things together. So really, this is a matter of the audience we want to tackle is the people interested in these kind of problems. And I think it's an interesting spin with respect to more traditional fields like physics or materials. And so we are looking into developing journals in this direction. So what I'm going and then, finally Nature Communications, where I worked for a bit, and I think you're familiar with it. It's online only, it's open access, and thanks to being open access, one order of magnitude more, they publish one order of magnitude more papers.
There is also scientific report.
Yes, but that's what I meant before. Scientific reports is not with a Nature name, so the actual model is different, right? That's really run by academics, essentially. So the academics make call the editorial decision. And basically the idea is that, once again, the breadth of appeal for papers that the editors look for, it's a bit narrower, and Nature Communications really wants to publish something that is important for a specific, narrower field of science. So basically what I'm going to talk about is mostly this layer here, where I work. So what the idea is, again, it's a matter of each journal really wants to target a specific audience. So basically, as editors of Nature Physics or behavior, what we do is really we try to think, okay, what can we publish that is going to be stimulating to our audience? Our audience is physicists, so what can we publish showcasing the whole breadth of physics that can actually make people interested in what we want to say? And in doing this, journals have, they publish the backbone of what our journal publish is really the articles, so papers, articles, and letters. But we try to complement it with a number of other pieces that we publish that hopefully can stimulate the discussion and really create a sense of community that, hopefully researchers can get interested in and get new ideas coming from it. So something like you're probably familiar with is reviews and perspectives, which are, I'll show you a couple, but they are kind of basically cross-sections of the state-of-the-art in specific fields, but made quite accessible, such that even non-specialists can hopefully kind of get a little bit of a feeling of what it is that is happening there. And then we complement this with what we call front half, where we really highlight interesting research, we write or commission news pieces, and we really basically want to foster a certain interdisciplinary environment in terms of the audience we cater for. So a few examples of things that we publish, I'm going to just quickly skim through it. You know, the sort of things that we look for, of course, you know, I'm a physicist, we look for physicists, we look for physics, you know, something like confining antimatter, anti-hydrogen for 1,000 seconds. That's the sort of thing that we feel, you know, even if you don't work with it, it's the sort of thing that as a physicist, you know, it's nice to know that this is what we can, this is the state of the art of what we can achieve. Something in a different field could be the fact that you can find scaling laws for aquatic locomotion to different regimes, and all various animals collapse on the same curve. That sounds like something that even people who are not familiar with that or might not really care about aquatic locomotion could find interesting. You have, of course, something interesting. We really look for also showcasing what's going on in the world of networks. You probably read some papers that we published in the last years where we keep a keen interest in that, both at the level of methods and, you know, structural understanding of networks, and at the same time also in terms of application. I'm going to talk about this a bit later. So these are the papers. Sometimes we publish something that, you know, we feel is quite interesting, but maybe it's not the most obvious to an audience, and that's where what we commission comes in, and we have an expert that writes their take on the paper. So these news and views pieces accompany our research papers, and they try to offer a bit more of a digestible discussion of why this is interesting and why they feel, in which way they feel they might impact the field. So, you know, we try to really kind of complement what we publish with commentaries. Again, like reviews and on various fields. Sometimes we package everything in special issues where we really want to sort of provide a bit of a spotlight on some topics. You have one of those hanging there, which was from a few years ago on complexity. And again, like more light-hearted pieces talking about issues that we feel could be interesting to physicists more generally, so CMOS computing or scaling between scientific levels in a sense. And also again, like we publish editorials where we sort of give our take on what we feel are interesting problems in science and physics. So this was in terms of mentorship. We had something on the job market in quantum technologies and discussing peer review. So anyway, this was basically the breakdown I wanted to give you, like in terms of what's in a paper. Now, in a journal, sorry. Now let's move to the black box, which is perhaps the most interesting part for you. So essentially, I gave you a little bit of an overview of what we try to do, which is select what we feel could be interesting for the community we serve. So how do we actually do this, right? So what actually is our job? The way most of you will interact with us is through papers, hopefully sometimes positively, more often than not, but we're gonna get there. So let's say the starting point, of course, where you approach the idea of submitting a paper to us is you basically put it together, and of course this is the part that is on you, not on us. But I think that understanding a little bit what we look for could be useful also in terms of putting a paper together. And really the idea is, as you probably know, we are quite demanding in terms of the format of the papers that we publish. By the way, that's something that we care about at the later stage of publication, so please, please, please don't waste 3 weeks of your time to get that abstract right exactly in 200 words. It doesn't really matter. If you have a paper that is a bit longer than required, or it has one figure more than you actually need, it doesn't matter. Just send it as it is. We can then fix it in the process. Don't waste all your time to sort of get the format exactly right. That's just not particularly a good way to spend your time before the paper is even selected for peer review. But basically, we actually want papers that are concise because we feel that this is the best way to communicate your research. So please make them focused. Try to really give a robust and clear, specific message. One of the most difficult things in putting a paper together is the fact that you often have too much to say, right? So select your message accurately. Really think about the story that you want to tell and stick to it. Of course, something that you really feel is important will probably be sidelined by your decision, but please, please, please don't try to package everything in a single paper. That's not what we really aim for publishing. We don't really feel that that's the most conducive approach. And really the sort of question that we want to get from a paper when we read it is, so what is the main advance? What have you done in this work that is, progressing the state of the art? What is new, and how is this pushing the field? All these questions basically lead us to establish why is it significant, in a sense. I will tell you a bit more how we actually evaluate papers, but basically these are the sort of messages that we want to be able to extract from a paper. So a well-written paper tends to be quite clear in terms of this. At the same time, as I said, we try to actually publish something that kind of cross-fertilizes fields. So one thing that we care about a lot is the context. People that read the paper are not experts like you, and we want people that are not expert to read your paper. So we hope that you can help them read your paper by providing the right context in which your results are presented. So setting the context is really a matter of making people understand what are the issues that you and your research field are targeting in a clear and comprehensible manner. By doing that, then, it's going to be much easier to actually spell out, why what you do is interesting and important and remarkable. And really, if you do all this, if this is done in a nice way, really the results will speak for themselves. There is no need to use massive adverts to hide the results. If you actually carefully explain what is an important open question in your field, and then you carefully explain how you are actually providing even only a partial answer to that specific question, this is going to stand out on its own. It doesn't need to be, you don't need to say that this is a breakthrough, because people will make up their mind on their own if it is or not, regardless of what you say. Still, the bottom line is we're not going to reject papers because they're poorly written. But if they are quite focused and quite clear in terms of what they achieve, it's much easier for us and for the referees to appreciate it. So our job as an editor, we are trained for reading papers, even pretty impenetrable papers and pretty obscure papers. But the clearer the papers are, the better it is for everybody. So the higher the chances for us to appreciate what's been done in the paper and for the referees to appreciate what's been done in the paper. So once the paper has been put together, the next step is, okay, this should be here. Well, anyway, yeah, okay, sorry, I skipped one slide, yes. So the next step after writing is submitting the paper. As you probably are aware, journals have very fancy and very large web pages with a lot of information on it. Nobody reads it for a reason, but actually sometimes there is quite interesting information in there. So make sure you familiarize yourself with the information in there. Now, one thing that we recommend providing at submission is a cover letter. Now, cover letters are kind of sort of like the elephant in the room often when you talk with somebody. And at least for our journals, I would say cover letters are not particularly crucial. People spend ages really thinking about what kind of cover letter to put, whether to put one or two logos of the universities, how many commas to put in the first sentence. It doesn't matter. We actually read the papers. So if a paper is remarkable in terms of the results that they present, even a terrible cover letter is not going to sink it. Okay? At the same time, cover letters are an opportunity for you. The way I see it is really the opportunity to have a coffee with me for 5 minutes and tell me why you feel that your results are really quite cool. So often what we do as editors, we read the paper and then we sort of like cross-check the paper with the cover letter. So we extract information from the paper and then we look at the cover letter and then we see, okay, did I actually get what they wanted to say? Or there is a bit of a disconnect. So, a good cover letter helps us appreciate and put in context what you've done. A bad cover letter is a copy-paste of the abstract, which doesn't add anything, because we have the abstract already. So really, it's something a bit more informal, so take advantage of that. But don't overthink it, yes?
What do you read first?
I typically read first the paper,
So that's
and then the cover
impression.
letter. Yeah. Because it's basically, kind of a sanity check, right? You read the paper and then you look at, okay, so this is what they've done. You look at the cover letter and 99 out of 100 is the same. Sometimes you go, oh wait, I missed that. And you go back to the paper. And maybe sometimes, sometimes what the authors feel is really the main achievement, and they spell it out in the cover letter, is kind of buried in the paper somewhere else. And so that's where, you know, a good cover letter helps you basically appreciate. But if the paper is put together nicely, the cover letter is, you know, less crucial, I would say. I'm not saying don't do it. Do it, you know, do it, but, you know, don't spend an excruciating amount of time thinking about it. That's not gonna make or break your paper, at least for these journals. We are happy, I don't know, there is this idea that nature and preprints don't really get along very well. That's fake news. It's not true. We're happy for you to place papers on archive or preprints more generally. The only caveat is that we ask you to put the first version that you submit on archive. Once we peer review your paper and we actually give you feedback and we give you advice in terms of how to modify the paper, that's when we actually ask you not to put that version on the archive because we started working with you. There is a 6 months embargo period in that. Nobody checks it, but I can say this.
It was 1 year, so it's now 6 months.
Yeah,
So 6 months after publication,
Yes.
you can upload the final version.
Exactly. But normally we ask you not to do it before that. Of course, if you know the peer review doesn't end well, then we will do it as soon as you Right. Okay. So this is now where, you know, you've submitted the paper, you've given it a questionable title, and this actually gets to our inbox. So this is where the black box begins. When the paper is submitted, it goes into a journal inbox, the journal you selected. As I said, they're independent, so other journals don't know, are not aware of what's in each other's inbox. And then an editor gets assigned to it. So editors, as I will show you in a second, each editor is responsible for a certain brief, so it's an area of science, in this case either physics, forget your physics, and they will be responsible for the paper from the beginning to the end. So the way editors are assigned is according to their expertise or background. Usually all of us, as I said, have been doing research, so typically our field of research is also the field we follow in terms of the papers we handle. But then, of course, you tend to broaden up and you have somebody doing quantum information handling networks papers. Hopefully well, let's see. And then, the idea is that each of us is responsible and they receive the papers. How many people do you think, you probably know, so don't say, but how many people do you think work at Nature Physics? And how many papers do they need to read? Considering that we read all the papers and we need to be able to cover the whole field of physics between us. For those who listen to my talk in Paris, don't say it, please. 100. No, it's not so many. Let's say, imagine how many papers how many papers do you think we read? Like, how many papers do I need to read every week? New papers, new submissions. 3. Say 3.
Why did you take this job?
50. Okay. Anything else? 100. Okay. So it's roughly 10 papers a week. So it's roughly 2 per day. And we are 7. So basically the way we split physics is shown on here. And so all of us follow certain fields of physics and we receive roughly 10 papers per week. This is thanks to the fact that researchers self-censor themselves quite carefully and don't just send us millions of papers, otherwise it wouldn't be 10 and we would have a problem. But luckily enough, we receive around 50 to 70 submissions per week, and then they are spread around the various topics. So somebody is gonna do, somebody's handling high energy physics, astrophysics. My brief is quantum physics and complex systems. Somebody else is doing biophysics, soft condensed matter physics. So each of us really has, a certain set of communities that they follow. And we always deal with the same people. We always deal with the same sort of like subset of physics. But of course, the interesting thing is that you come in from research where you have, a much more specific interest, and this gets naturally much broader. as you can see, they are very kind of like coarse-grained categories. So what happens is that then once the paper is submitted, we take a first decision, which is the dreaded desk rejection that Alex mentioned. So this is really where we decide, okay, does this paper have the potential to be the sort of thing that our audience wants to do? Does this have the potential to be the sort of paper that we feel we could consider publishing? Roughly, we try to take this decision in 10 days, on average. At Christmas, it's definitely not 10 days, but it varies a bit. And what we do to achieve this decision is we read the paper carefully, we write down what it is about, and then we read the related literature to get a feeling of how is this doing compared to the state of the art. So the sort of questions that we ask ourselves when we do this is, what's the originality of this paper? So what's in the paper, has this been done before? If the answer is yes, then probably everything stops there. Most often the answer is no, and then the question is, okay, so this is new, how new? In which way is this new, right? So for instance, is this a matter of maybe changing the model a bit, changing a few parameters, or is it really a matter of like finding out a new direction, a new model, and so on? Of course, usually it's in between, and that's where the grayscale comes in, but really we sit down and think, okay, so is this step forward a substantial one or not? And then we basically try to evaluate this in terms of, okay, so this new step forward, what's it gonna unlock? So what are the implications of this new step forward? Is this something that potentially many people will be interested in? Or is this something that, like as I said, maybe it's tweaking a model? Yes, of course the people who work on this model are gonna be enthusiastic about it, but that's pretty much it. So really it's a matter of trying to gauge what the implications of a certain result can be. And these implications can be at the level of practical applicability or even economic impact. Of course, for nature physics, that's not really the case, but other journals look at the impact in a broader sense. What I want to stress is the fact that, because maybe it's easily you can go, how the hell can you do that, right? And the bottom line is that this is an editorial assessment. We are not experts in terms of technical understanding of the papers that we handle. And even if we are, because our background is exactly on those things, that's still not our job. So I'm not going to check if the results are robust and if what you claim is really carefully, substantiated by what's been done in the paper. I mean, if there is a massive disconnect, I can spot it. But this is an editorial assessment. So I basically look at what has been done and if this has the potential to be interesting. That's it. The technical assessment is where we actually consult referees for. And there is a very kind of stark division between state and church, right? We look at the editorial matter and the referees look at the technical matters. There's quite a distinction. As I said, we tend to be quite selective, and we feel that this is the moment where our selectivity can be most helpful in terms of selecting what you guys read, but also in terms of not making millions of referees waste all their time refereeing a paper that then is just not editorially interesting enough. Yes?
What do you do with the referee comment that the paper is not of editorial interest?
I'm going to get there. 1 second. And as I said, this is the bit where we are quite selective, and roughly 80 to 85% of the papers get returned to the author at this stage. Now, when we do this, you get a rejection letter which has a little bit of feedback. Now, everybody that starts as an editor, they go, okay, I really want to be helpful, I really want to tell them why what they did is not going to be suitable for a journal, and you give very detailed reason, very carefully put together, and then people argue with you a lot. So basically you go, this is the reason why you reject the paper, they go, yeah, okay, I see what you say, but what about that? And then you respond like, yes, okay, I understand, but this and this. And you go, yeah, no, I understand, but what about this? And it just takes forever. So our letters tend to be quite vague, and it's kind of a design reason because we just can't cope with the sheer amount of arguments that come back to us. However, this is not to say that we don't really think about the papers that we receive and that we don't consider. So if you actually get a paper declined, feel free to email me or feel free to email the editor that did that to ask for a bit of an explanation. They will be happy to provide it. But it's just a matter that they tend to be vague because it's just more efficient for everybody. So the remaining 20% is sent out to peer review. if you're interested in the details of peer review and how actually it works, I'm not gonna talk about this because otherwise it gets too long. But I think fun fact is the fact that people think that peer review is sort of a very established thing. Actually, Nature started peer reviewing the papers systematically only in 1967. Before 1967, the editor-in-chief of Nature would just go down the road to the pub and talk to a few academics from Cambridge usually and decide what to publish. So it's other journals have done this since a longer time. Maybe, but at least this is there since a few decades. Yeah. And I think that a fun story is the fact that in maybe you heard about this, but peer review is quite a modern idea. In 1936, Einstein sent a paper to the Physical Review journal. Physical Review sent it to a peer reviewer who found some issue with something and then invited Einstein essentially to revise and resubmit its work. And what Einstein responded was, dear sir, we had sent you our manuscript for publication and had not authorized you to send it to specialists before it is printed. I see no reason to address the, in any case, erroneous comments of your anonymous expert. Referees were wrong also 8 years ago. On the basis of this incident, I prefer to publish the paper elsewhere. So, and this was not 200 years ago, right? So it's a peer review, everybody kind of assumes it's a very well-established practice. It's not been around for such a long time. Which is why we're trying to experiment with a few different other alternatives to peer review, but which are double-blind and transparent peer review. Ask me about it if you want, otherwise this goes too long. So peer review, right? What happens at the stage of peer review is really quite crucial because we are the ones that select and invite referees to referee the paper. As we read through the paper, we usually identify the various areas of the paper or the various technical sort of like building blocks of the paper that we really need feedback on. And on the basis of that, we assemble a team of referees that can really help us understand if the paper is solid. So what we look for is to cover relevant technical expertise to assess the paper. So for instance, if a paper has a certain specific experimental technique that the authors use to reach their conclusions, we want somebody that is familiar with that technique for sure. Maybe even people that haven't worked on that specific problem but are familiar with the technique, and so on and so forth. So for making an example which is perhaps more relevant to here, if you have a paper that uses network science to make claims in terms of epidemiology, we probably want somebody that is an expert of the application side, and is familiar with kind of like the nuances of epidemiology, even if perhaps they might not be super experts of the rest, which creates all sorts of problems, I imagine. But that's the angle we try to take, because we want papers to be assessed and looked at from different angles. We try to find people that are not subject to conflict of interests, and then we actually look around for them through our own knowledge, or we listen to your suggestions. We invite you to suggest referees when you submit a paper, and we actually listen to those. It's a good starting point for us to find people. Sometimes we usually maybe use one of the people that you suggest. We usually wouldn't go more than that. The idea is that we always try to find new people to referee papers, and so on the one hand, people that we have used in the past as referees, and we know that they are reliable, we tend to contact them perhaps again. But since we try often new people, they might not always be as fair-minded, as constructive as we hope, as we know. But really the idea is we try to look out for different people. And we also try to assemble teams of referees who are as diverse as possible. Now, actually, this is something that is this is basically one of the things that is the hardest to do, as you can imagine. And in that sense, if you actually happen to submit a paper to one of our journals, when you suggest referees, please keep diversity in mind. That's something very helpful for us, particularly for researchers based in countries where it's not very traditional to have nice websites. It's really hard to find them for us. So please, if you know somebody that is a very well-established researcher that you would like to actually have as an audience, and they are sitting in a country where it's a bit harder for us to find them on Google because of name issues or just traditional issues in terms of websites, please suggest that. That's really helpful for us. Otherwise, we always end up kind of going always to the same countries where people are more visible. And actually, just to give you a little bit of a background, we really try to find different referees. So this is a breakdown of the referees that we used in nature physics over 10 years. And as you can see, most of the referees we contacted have refereed for us a couple of times over 10 years. A few have refereed quite a few papers, but that's often when we have multiple submissions at the same time and then we get the same referee. But really, we try to diversify the pool of referees. We don't want to have the same, like 20 people refereeing for us over and over again, which would be kind of an informal advisory board. Now, so we contact referees, we get back the reports, and then what we look at is essentially the degree to which the criticism of the referees are undermining the validity of the conclusions. Now, this is of course a technical angle, so there is a technical angle here, which is, if a referee casts doubts in terms of you cannot say this, or you don't have the evidence to say this, and that's a particularly complicated situation. We never ignore technical problems. However, of course, we also care about what the referee thinks in terms of the editorial interest of a given paper. This is where, as I said, this is our job. So the editorial decision is ours, but of course these are experts. These are people who worked their whole life on a specific problem. And so, the fact that they might not be very impressed about something is a little bit telling and is a little bit concerning. But we kind of keep into consideration their feedback in terms of our own understanding of the paper. And particularly, we actually weight the feedback according to the background that the referees have. And that's quite crucial because, as going back to the same example as I made before, if I use a referee because he's an expert of the application of your paper, and this expert has problems with the model, in terms of this model is not new, it might not be the most relevant criticism if the modeler is actually quite interested about the model. So this is really different referees look at papers in different ways, and we kind of weigh their opinions. This basically means that even if referee number 3 is positive, it might not be particularly meaningful depending on who this person is. So sometimes, keep this in mind when you say, oh, but referee 3 is positive. The other 2 are idiots. It depends. and when referees disagree with one another, which happens all the time, we typically take a stance and somebody's going to get overruled, but we do this only on stuff that is not technical. If there is a technical problem, we are always going to listen to the referee. And I'm going to tell you in a bit how you can let us know if you got it wrong. One thing we try to do is really, we don't want to drag papers for too long. So I know that this is the most frustrating thing that you encounter when we basically step in and stop the scientific discussion by rejecting a paper at some point. But basically, we really don't want reviewers to have to read the same paper over and over again many times, and you spending a lot of time kind of fighting back and forth, because that just basically means that the paper in whichever journal is going to get published way after it's actually probably going to be timely. So really, sometimes we take decisions which you will find frustrating, but they are in the interest of time of everybody involved. As I said, usually we ask referees to give back their feedback within 3 weeks, which typically means we wait 2 months, but people are busy and we understand this. Anyway, the bottom line is we don't count votes, we look at the advice and the substance of the reports. These are put together and we take a decision. The decision is with the editor. Roughly 50% of the papers get rejected at this stage. 50% of the papers that have been submitted to start with, have been sent out to review to start with. So. Just a little advice. When we actually invite you to revise your paper, feel free, we expect you to respond to everything that the referees have brought up. When I say respond, it doesn't mean do everything that the referees are asking. Don't ignore what they say, but you feel free to disagree, right? And give scientific reasons why you feel that whatever they're asking is not relevant to the paper in consideration. Possibly, if you do this, do it politely. And again, when you resubmit papers, you still have the opportunity to have the cover letter as your informal coffee with me, right? So feel free to be more informal and talk to me if you have a problem with some of the referees or with something that has been brought up. So it's still another angle. We typically try to close this circle in 2 rounds. Acceptance. I mean, if you do the maths, between 5 and 10% gets accepted, and then the magic starts. People who are actually talented at figures come in, redo the figures, copy editors rewrite the paper a bit, and so on and so forth. Just one thing I wanted to flag is the transfer of papers. As you know, we have many journals, and you can move your paper between them, and this is something that we offer you basically when the paper gets rejected, either pre-review or post-review. And basically, essentially the idea behind this is to offer you an opportunity to find a new home for your paper as quickly, as effectively as possible. So as I said, we are all independent, but sometimes we might talk to the other editors when we have a paper that we are about to not consider, but that we feel could be a good match for their journals. This is something that you can select to prevent us from doing. So when you submit the paper, there's a button, and if you tell me, don't talk to anybody about this paper, I'm not going to do it. The idea behind transfer is that essentially the transfer without review is really a matter of not having you to resubmit all the affiliations of all your co-workers, which takes forever. And it's not really something that has, comes with a penalty. If Nature rejected your paper, I am not going to say, oh, they have been rejected from Nature, I'm clearly not going to consider it. I mean, it's two different journals with two different audiences. It doesn't make a difference for me if your paper was not considered in Nature. So don't hide it. There is nothing to be lost there. So really, there is no drawback in transferring paper downstream. Transferring post-review, however, are a bit more tricky because this is where it really can save you time. Because if you transfer a paper after it's been reviewed, we actually get, as the receiving journal, we receive the reports and the identity of the referees. So the idea is that we can basically carry on the refereeing process without starting from scratch, which is useful for you and saves a lot of time. However, this is not something mandatory. As I said, the journals are independent, and if you feel that the set of reports that you received at a certain journal, it's just not going to be worth fighting for, you resubmit your paper fresh at another journal, and nobody's going to know that this has been reviewed. Now, unfortunately, the same referee might be contacted because the world is not huge, but that's not deliberate, right? We don't know who refereed the paper. So don't transfer if the reports were bad. Final word of advice, appeal. You can always appeal all our decisions. The point is, it depends a bit why we took the decision that we took. So decisions that are based on editorial judgments, either pre-review or post-review, because we just feel that the paper doesn't have the potential interest that we look for, these are the ones that it's a bit difficult for you to overturn. Feel free to do it, but it's not very likely that we're going to change our mind. However, if you appeal on technical grounds, because you really feel that the referee got it wrong, or the referee is saying something that is just scientifically ill-based, please, please, please appeal. We trust our referees blindly, because that's the way the system is designed. So if the referee got your paper wrong, we have no way of knowing. Please appeal if the decision was actually based on flawed interpretation of your results or just technical misunderstandings. Also, feel free to appeal if, basically the referee goes, this paper is nice, but, you're never going to be able to do this, which is really what you should be doing. And if you actually can show them that you can do it, feel free to come back at us. Anyway, we're open for this kind of discussion, so feel free to contact us and ask our opinion on the status of the paper. Try to keep the whole discussion scientific and present data as much as possible to make your point. Don't fight when you appeal, please. So the sort of thing that we don't really find useful is if you just change the abstract and resubmit the paper, that's not going to cut it. Telling us how important you are and how many papers you published is not necessarily going to help you, mostly because we probably know already. The fact that some Nobel Prize thinks that your paper is amazing is also not very useful. I mean, it's very good, but the idea is that our judgment is not a matter of how important the paper necessarily has to be. It's really like we look for a number of things, and clearly we all know that there are those papers that by adding that epsilon, they generated a massive revolution. That epsilon is basically very hard to find, and even if some very important person thinks, okay, this paper is groundbreaking, there are many groundbreaking papers out there. I'm not going to publish all of them. Please don't think that referees are idiots, unfair, or they are completely scientific illiterate, because the referees who everybody thinks are unfair are typically the ones that they suggested. So just don't say it. Don't guess and attack referees. Particularly, don't guess and just send them an email saying, oh, when you reject my paper, why did you do that? This happens, so please don't do this. And don't tell us that we publish worse papers, because it's probably true. We are not happy when you tell us, and also, every paper has its own history, so it's very difficult to make like head-on comparisons, also because, you know, in time things change. Yeah. Just one thing I wanted to flag you, finally, is the fact that most of our journals are behind paywalls, right? Nature, Nature Physics, and so on, they are behind paywalls. However, since a few years we offer the opportunity for sharing for free these papers. So if you actually, so the location of the thing where you can generate the link keep changing. It's somewhere in the HTML file somewhere. Now it's under the section about this article. So if you have access to a paper behind the paywall at Nature, you can generate a link that then you can use to share this article for free with anybody. You can put it on social media, you can email it to your friend, to your grandmother, or whatever. And people can click on the link and read the paper without the paywall. So that's actually kind of a way to disseminate it a little bit.
When did it happen?
Huh?
When did this happen?
2 years ago, I would say. And again, like, feel free to put it on social media. That's fine. I think that this is all I wanted to tell you. Sorry I ran a bit over time. Thanks a lot for your attention.
Thank you very much, Imogen. A lot of questions. Let's start.
I think it's a really difficult job, so I just want to...
Thanks for your understanding.
Two-stage question. So I assume like there are papers that you say, I'm really glad this paper is published in Nature, right? Because you oversee an entire process. So same authors can also publish another paper or submit. So how Nature editors can kind of like eliminate the individual biases. So since all of them are published in a LaTeX format, is there a way to like blinding the authors or different methodologies? Did you ever test it?
Yeah, so that's something that we are looking into. We have not tested it yet. But this is what some people call triple blind, essentially. So double blind means authors and referee don't know one another. Triple blind means also the editor doesn't know who the authors are. Now, it's clear that some bias is going to be there. I mean, as much as we try to do a good job, you know, it's unbelievable if I tell you we're never swayed by these things. But we try hard to try and, you know, evaluate papers on their actual merit, not on the names of the people who are on the paper. Of course, there are a number of technical difficulties in terms of like finding referees if I don't know who the authors are, but you could imagine a system where basically the moment I click to send the paper out, then the kind of like the blinding gets lifted. The fact that we have a submission system that we're very proud of having been one of the first journals to have an electronic submission system, but we never updated it. So it's basically the same thing from the 90s. That is preventing us from doing all these fancy tricks, but we are going to experiment with that. But basically, when you train new editors, you really try quite hard to prevent that, and you try to give a fair chance to everybody.
Can I ask just a follow-up? So is there no quality control checkpoint where, like, once you say yes, the reviewers like it, I like it, it's going forward? And at what point does?
I mean, essentially, at the first approximation, no. So editors are responsible for their own subset of content in the journal. Chief editors look at everything. So before I can accept it, my chief editor has to say yes. But they typically look at the technical correctness of the procedure. So, you know, if I have enough referees, and if the referees were not saying, what are you doing, and I'm still accepting it. But the quality control is internal of the journal.
What kind of training? You just said training, right? So like, and it is different for different journals. The ones that you get.
Yeah, well, there is a bit of a difference between different journals, mostly because you look for different things in papers. So you look for a different audience for each paper.
Yeah, but what's the process of training you?
I mean, essentially what you do is you run everything through another editor whose job is to make you change your mind, essentially. And you basically confront and look at things in different ways and stimulate your critical sense, in a sense. The idea is, you know, and one of the parts of the training is also to make sure that you become more efficient at reading. Because, I mean, one of the things that we learn how to do is, and you have to be a little bit skillful at that to actually get hired in the first place, is, you know, I give you a technical document on a field that is not yours, and you need to, in a reasonable amount of time, extract the most important information from it. So the training is a matter of making sure that the person who is getting trained didn't miss something, and then, questioning what is their interpretation of that, and checking the literature, and basically pointing out and really kind of stimulating the sort of critical sense in terms of like finding out what are the main points of the paper, and benchmarking this against the literature in a way. But training doesn't mean that we brainwash people. So we don't really tell them what to do. What we want to do is stimulate the critical sense in a new editor in terms of equipping them with the skills necessary to make these decisions. What is then the final call, as long as it's editorially well put together, we typically don't disagree with that, unless it's clearly off the mark.
Okay, so we all know that the Asia Publishing Group is a for-profit group, so
Yeah.
there are quite heavy publication fees. So I was just wondering if there are mechanisms for third world countries to publish in Nature. Do you occasionally occasionally waive the fee, or if you see that the paper is good but it's coming from literally the group that cannot afford the publication?
So, first of all, I mean, the answer to the first question is yes, and the answer to the second question is no, meaning the people who decide whether you're gonna get your fee waived or not are not editors. So it's not a matter of how good the paper is. This is in the manual. I think that Hinari countries get all the fees waived automatically. For other submitters, there is basically, I think I have it, there is a website which is, if you Google like Nature Publishing Group funding, there is a website, there is a portal where basically there is a team that is dedicated to looking at who you are and deciding whether they waive your fee or not. Usually when I was working in Nature Communications, everybody who asked me to waive the fee, and they were reasonably unable to pay, because I mean, if you ask me to waive your fee and you are from, I don't know, here, let's think.
Okay, guys, you see that it's not going to happen.
Then typically the answer is no. But if you actually have a problem, then yes, the fee gets waived. But this is for open access journals. For paywall journals, usually what happens is the only charge is for printing color figures, which is kind of ridiculous in 2018, and that's really something that it's kind of, it's not like, I mean, it's, again, it's a case-by-case basis.
I have one question.
Yes.
That perhaps you might not know. So Nation now has opened a new journal. It's called Machine Intelligence, Nation Machine Intelligence, and it has received a lot of criticism from So do you know?
I happen to know, yes.
Yeah. So
You made
I
right
have my stand as well. You know, it's
Yes.
but you know, do you have any idea how it's going? So is the community submitting papers, the journalist picking up some momentum, or really there is a kind of adversarial attitude from the community?
So I do not know the specific numbers of the journal. I would say that I mean, starting from the point that the people who actually signed the boycott are not sending papers, I think that they are still, there's still quite a big community out there that they want to cater for. And I think that one source of misunderstanding a bit in this is that really there is quite a, like, the people that drove this criticism are quite rooted in sort of machine learning. And what this journal is trying to do is actually looking at a bit of a broader set of communities and bringing them together. You can call them like, it's kind of a thematic journal if you want. They actually, you know, want to publish robotics papers, automation papers, and these people are, as far as I know, very happy to work with them. So let's say there is a community with which they seem to have a problem, but there is still quite something out there. The hope is that, you know, maybe as things go ahead, they sort of maybe see how the journal is going, and they seem to maybe like the way that it's run, and hopefully they will resolve the difference. That's what I don't know if they are really facing huge problems in terms of the number of submissions. I haven't heard that, but I don't know.
But I don't know what's the story there. So why machine learning people are people?
Because machine learning is in computer science, and computer science is usually publishing in proceedings, and so the idea that there is a cost associated to the publication seems kind of outrageous to people in the community. In addition, there is all the proceedings are generally open access, and so, you know, all the community is saying like that. I have to say my stance that it's not true that conference proceedings are free, because you have to send one person to speak at the conference, and that generally is more expensive than yeah, that's we have to be. I'm part of that mechanism too, but I send the people to dab, and it cost me $6,000 because it's in Australia. And if nobody's presenting, the paper is not going to be published. So, things like that. But it's true that, the idea that you have anyway a paywall for the community is a little...
So I think my understanding is that there is the Journal of Machine Learning, which my understanding is it's community run, it's open access with very little expense, and they seem to be very satisfied. So essentially they go, why you, big bad publisher, come in and you put a paywall and you make everything more expensive, what's in for us, in a sense? I think that was their angle, and it was very much on open access, yes.
So the history of it was that there was a machine learning journal that was by Springer, and it was closed access.
Yeah.
People did not like it. So people boycotted that,
Exactly.
and they came up with Journal of Machine Learning Research. There's an equivalent of it in Journal of AI Research. So you were talking about planning and robotics. And so the review cycle is very quick, and everything is online.
Exactly.
And so the question is, as a machine learning person, why should I send to Nature Intelligence when I can send it to JMLR, Journal of Machine Learning Research, where I get my reviews very fast, and where people actually go and look at it. And for that, I don't need to send somebody to proceedings. I agree with you in that, like when I
I was
publish
thinking
at
about this.
ICML or
I think
NIST, I have to
this is-
send somebody, and that is a cost.
The first
Right.
letter was more on, then the things got, but,
Right.
I just
But
think
the
that
one
this
thing about conferences is, in computer science, is like being on the 7 o'clock news, right? So you pay to be on the 7 o'clock news, and everybody sees your work, right? And maybe publishing in Nature is similar to being on the 7 o'clock news.
I would say that that's a bit the angle. That's basically the way I understand how the journal wants to sort of complement those existing journals. I mean, I don't think that the idea of these journals is like, I'm gonna take the spot and kick those other journals in the dust. I mean, this journal is gonna publish 100 papers a year. I don't know how many they publish, but I would guess more than that. I'm not sure.
It depends.
I don't know. So let's say the understanding I have, not being familiar with this community very much, but talking to the editors, they basically go like, we want to sort of like highlight perhaps what we feel is the most relevant coming out of this broader field and complement the existing journals. But the community seems to basically argue we don't need that.
So I guess the question is, who's the audience, right? So is the audience going to be the machine learning people, or is the audience going to be the nature reading people, right? When I submit a paper, it's about is this audience going to appreciate this paper or not, right?
Absolutely, yeah.
And so if I'm a machine learning researcher, I would like machine learning people to read it, and
Yeah.
usually.
Ideally, what this journal wants to achieve is to make their papers read not only by the machine learning community, but other communities engaged in that from different angles like AI, robotics, computer science as a whole. I'm not super familiar with the journal, but I think that the idea is basically, you take a number of communities, I don't know how many, and you basically put them all together in a journal. So you hopefully bridge between them.
I think there is also a lot of focus on the application, if I'm not wrong.
I think so.
So for instance, let's imagine that you have machine learning for, diseasosome or whatever. That would be a very hard token because there is no innovation in the machine learning algorithm, but actually the innovation is in the application. And what do you do in that case? You send to a medicine journal, but as well, so it's something like, I think,
I think the overall goal behind it is essentially also to sort of, taking it with a pinch of salt, but let's say the idea is, these are fields that are becoming quite important for the public. And so we see merit in maybe making people publish them in a venue that sort of forces you to be much more transparent and understandable in terms of the language. Whereas if you publish in your own community journal, necessarily you're going to have a paper that is rather technical. There is nothing wrong with that, but it's a matter of like, we hope that we can kind of like make it a bit more understandable to a broad audience. Let's say and then the question is whether we actually do it or not. And then, I leave this to you. But the idea would be, my argument would be, if the Guardian covers a paper in AI, coming from machine intelligence, probably the reporter of the Guardian will probably understand it a bit better if it's from machine intelligence and there is a number of press people involved that can kind of digest this for the journalist. If this paper is published in a technical journal, even if it's open access, the reporter might not even cover it, or they might not necessarily understand all the knobs. And then the question is whether the reporter is good enough to actually do that. That's another matter. But let's say the idea is, to kind of like sit in between.
Okay, now let's open the discussion to your own paper submitted. So let's go. Okay, thank you very much again.